So we're now ready to start showing some examples of how to actually use Spring Boot and Spring WebMVC to do a non-trivial application. And the application is going to be called the PrimeCheckApp, and it's going to be a case study, and we're going to have a bunch of different parts. We're going to break this down a piece at a time. Where we're ultimately headed with this, and we should get this done this morning, is to show how functional programming and the Java Streams framework can be applied in a case study that uses Spring WebMVC to check the primality of large random integers in a client-server environment. And you can get this example here in the EX1 project in my WebMVC folder in my Live Lessons GitHub repository. So let's first give a big picture view of what we're going to be doing here. So we're going to be using Spring WebMVC to send and receive HTTP GET requests to and from clients and servers that can either be sequential or parallel. And these are all going to be little knobs that we can tune and tweak in order to see the difference that arises when we do things in parallel or sequentially. So that's the big picture view. We've got this client app and a test program that drives it, and it'll send a bunch of requests to a PrimeCheckApp, which has a controller and a service, and they check to see whether the numbers are prime and then send the results back. The client can send these requests either individually, one at a time, like here's a random big integer. Is it prime? Here's the result. Or it can send it in bulk. Here's 500 random integers. Are they prime? And get a result back. So that's one thing the client can do. And it can also do this either sequentially or in parallel. And we'll see how Java Streams let us make those decisions in a very convenient way where you can tweak and tune it at runtime to get the behavior you want. The server, likewise, can receive requests either individually, one at a time, or in bulk, a list of these requests. And it can also process the requests sequentially or in parallel using Java Streams and then send the results back to the client. So again, we've got all these different dimensions, and the program that we'll look at eventually is very cleverly written, so you just have to pass in a few flags, and it does the right thing, and it allows us to be able to do very fine-grained benchmarking of performance and show the pros and cons of the different approaches. This thing called the PrimeCheck controller automatically converts HTTP GET requests into Java native types, like integer or string or list of integer and so on, and then forwards them to the PrimeCheck service to be processed. And the PrimeCheck service checks the primality of the integers that are passed to it from the controller using either sequential or parallel streams. And we'll take a closer look at this stuff after we walk through the big picture of it. So let's talk briefly about how this app is structured. You'll see that most apps written using the Spring WebMVC framework have a structure sort of like this. So the PrimeCheckApp source code is organized into several packages. This is just looking at my package viewer in the IDE. There's the server package, and that contains three things. And this is very common when you write this type of application using Spring. There's something called the PrimeCheck application, which is the entry point into the entire application. This is a so-called monolithic application. We'll talk what that means later. So it means everything is running in one process. We have a PrimeCheck controller. That's the thing that takes requests and converts them, HTTP requests, and converts them into native calls on Java methods. And then there's the PrimeCheck service, and that's what actually does the business logic. So this sort of triad of classes and decomposition is very common. And so I like to structure almost all my programs like this. It's easy to figure out what's going on at a glance. When we talk later about microservices, you'll see that you typically have each microservice organized like this, but there could be multiple microservices. Here we just have a single service, which is the PrimeCheck service. There's also a client, and the client writes the logic that sends the GET request to the server using either sequential or parallel streams. And as you'll see when we look at the client, it is very cleverly coded to try to abstract as much as possible from the way that Spring converts native types, like lists or integers or strings, into the underlying mechanisms for sending this to the server using URLs. So that's abstracted and hidden in a very clever way, using some really cool methods and classes in Spring and WebMVC, such as REST template. So that's the client and it can either use sequential or parallel streams to do its duty. Then there's a test driver, and this is a Spring Boot test, and it does a bunch of things, but most importantly, it measures the amount of time taken for each of these different strategies to send and receive the request to and from the server, and then it displays the results. So this will allow us to do an apples-to-apples comparison between the different models of concurrency and the different models of bundling up the data into either chunks or individually making calls, and see what the consequence is on performance. And then there's a couple of other packages. I probably could have combined these. I have common and utils. They could probably both be under common. And they just consolidate various helper classes. We have something here that times the results, keeps track of the options, keeps track of ways of making invocations that hide the fact that URLs are being used to send the data. And then there's various things that we use to make it easier to program clients and servers so they don't get out of sync with respect to how they talk via HTTP and the put and get messages and so on. So that's the end of the app case study, the first part, part one.